Okay, so I've got a animation here. And I got this variable z. I'm defining z as used smartphone memory space. Did I talk about variables versus parameters in that the video class? Was that part of the video class I had you watch over the weekend? Variables versus parameters. So would z be a variable or a parameter? If z was the used smartphone memory space, say in your smartphone, your used space, is that a variable or parameter? Okay, why is it a variable? Right. So there's always what? There's always things coming and going on your smartphone, and your used space is changing, right? Okay. So relative to the variable z, so I'm showing something visually here that relates to this variable z. So what might the red bar represent relative to this scenario z, and what might the blue bar represent relative to variable z? So I want you to talk for 30 seconds. See what you think. What does each of those, the red bar and the blue bar, what do you think those represent? Okay? And I'll give you an extra hint. One of those is representing Z. One of those, either the red or the blue, is representing Z.
Not both?
One of them. One of them represents Z. Okay, go. Keep talking.
Oh, that's such a low amount of violation. It's memory space. It's not data. So imagine your phone having only 3.5 gigabytes. Only half that much. Yeah. Download. So it's kind of like test.
Okay. Jessica, what did you guys think? So, she wants the red bar is Z. Agree? Some nods. Yes, the red bar is Z. So that's showing how much used memory space. Okay. What about the blue bar? Yeah, what did you guys talk about? Okay. So Z is the amount of memory space used in your phone. So it's like how much, and so that bar then is just like an x coordinate is showing starting from 0 how much is used up in your phone. Make sense? Like an x coordinate. So then what might the blue? What did you guys talk about for the blue line? So so you're looking at this and saying this is the total memory available on the phone. Okay. So no, this is a real phone. It's this, what's that? Okay. So let's say that this phone is a 16 gig hard drive phone. Yeah. So what could the blue bar represent? A change in memory space. What causes a change in memory space like this? Download something, right? You download something, and there's a change, right? So we're going to call that DZ. DZ is amount of change, right? So there's amount of smartphone memory space that be used, and then you want something else, that's going to be a change. Is change a verb or a noun? Is change a verb or a noun? In this setting, in this context.
The change is a noun.
Yeah, the change is a noun. It's an amount. It's an amount of change. What's going on back there? You guys focus? We need to split you guys up. Okay. So do you see that change in this context is a noun? It's an amount. About how much? Here. Just something. Is it 5? Is it 1.5? Something like 1.5, right? It's the amount of change, like how much, something you downloaded was about 1.5 gigs. Okay, so that being said, let's do a few questions here. So in a little while, a week or so, you guys are gonna. Oh, I'll tell you at the end. Okay. Here we go. So here's a couple questions. So there's a couple scenarios there, maybe. And you're going to, in each scenario, I'm going to give you 2 of the 3, and you're going to compute the unknown, and then write a formula for the unknown. So you, based on the situation, you figure out which 2 you know, and which one you don't, and then based on your understanding of initial, final, and change, write a formula to what would compute that unknown. What would you do to compute the unknown? Write it as a formula. Is the task clear? Okay, go. So do it for number 1. So, Andrea, in the first example, what did you say was Z initial? Was that known or unknown?
I'm sorry, what?
Z initial, known or unknown?
No.
And you?
It is
3. Good. Z final?
Z final is known. It's 5 gigabytes.
Okay.
DZ is unknown, but obviously you can solve for it.
Okay.
It's going to be 2 gigabytes.
That was our unknown. And so then what formula would you write to compute that? So DZ equals what?
DZ equals Z final minus Z initial.
Agree? Agree with that? Agree with that? Okay, cool. What about the next one? So you guys up here. What'd you say? Did you know Z initial?
4.4.
And by the way, for this, I'm showing number 1 now, right? So I'm showing an animation that shows number 1. Okay. Number 2.
So 4.4 is ZI.
Okay.
Our ZF is unknown. So that's going to be.
Okay.
Our DZ is 3.5 gigabytes.
All right.
To compute ZF, it's going to be ZI plus DZ.
And why that? Can you explain that formula? Why? So why does that make sense?
So you start off with the initial amount, which is ZI,
Right.
and then you add on the amount of change, which is given 3.5 gigabytes to get you the final.
Well said. Right? Should make perfect sense, right? Wow. But when things get hard in calculus, this concept just goes out the window. Okay. It really does. Like you get a little bit more complicated, other things going on, and suddenly this seemingly simple formula is kind of not fully grasped or not fully accessed, okay, and understood. So what'd you get for Z final then?
It's going to be 7.9.
7.9. Okay, so I'm going to change the animation, and I want you to think or talk about the difference. All right, you got an image of what I'm showing you there. So now what about this? That's weird. It's at the top. What's the difference? Do you see it? So I'll show you before and after. Ready? Here's before.
Oh, so now you have the Z final, and then you're calculating DZ as you're going along.
There's exhibit A, exhibit B. So talk about it. What's different and why? So what's different and why? Talk.
So you're like, I started off using 3, now I'm using 4, now I'm using 5. From the beginning, I used 2 gigabytes of data. Now we're just calculating. Like, let's say, what's your current? Guess what your current usage is. Like, let's say you're using 16 gigabytes, and then next month you're at 17. The next month you're at 20, and then your DZ, just your change from your initial 16 gigabytes you used, all the way through that month and the next month.
Okay, you guys are quiet. Just 10 seconds. Got it all talked about. Karen, what? So it's not just a change, but a changing change. What'd you guys, Sophia? What'd you guys talk about? Okay. Okay. All right. Good. And Brandon, I heard you say something. Okay. Okay. And here? What do you think about that? Yeah, that's right on. So now, and this is the way we want to think about DZ. We want to think about DZ as a variable. It itself changes as Z changes. Yeah, sure.
The way you said that.
Okay.
And I'm guessing it's probably my incomplete understanding. If DZ is changing as Z changes, does that mean it's dependent upon the change in Z? Because that seems kind of backwards to me, unless I'm absolutely not needing to be thinking about this way.
Is what dependent? You said
the way you said it, it made it sound as though the change in DZ was dependent upon the change in Z, which seems kind of backwards to me just from a formula standpoint, and that may be my problem.
But the change in Z is DZ, so I don't understand your question, right? So
well, and this may be part of my problem too.
Yeah. So yeah. So Z, if our Z initial is 3, then the given value of whatever Z is as it's changing is dependent on how much change there is. Does that help? Because yeah, so we could pause this at any time in here, right? And so now the current value of Z is dependent on how much change we've seen, or maybe what percent of the download is done, right? And then come a little bit later, now we got a larger percent of the download, and so you have a greater value of DZ. There's more of the app or file has been downloaded, and so currently your DZ is greater than it was before. Yeah.
There's something I kind of want to ask. Is DZ always a variable, or can it also be a parameter?
So for our purposes, we're going to say it's always a variable.
Okay.
As we kind of start this journey of thinking about calculus, it's going to be a variable for us.
Okay. Yeah. It's just because I believe in your online class it was parameter before, so I might have been wrong.
Delta Z. So delta, and then also we're going to in a little while talk about delta Z. That's a parameter.
Okay.
Delta Z is a fixed width that we're going to pick and use it over and over again.
Okay.
And DZ is going to be variable through intervals of delta Z.
Okay.
That's a preview of things to come. All right, and then in a little while, so maybe a week, in the next couple of weeks, once we have all the tools and all the things, we're almost there. You're going to design this animation, okay? And this is going to be kind of the first harder one, right? So, but we still have a few more tools to get in our tool bag, all right? What's that?
I hope so.
Yeah, yeah. Okay.
More guesses to be made.
More pre-calculus to learn. Okay. Here we go. Where are we at now? So let's do this. Okay, so you guys said dy is computed this way, right? Y final minus y initial. We just said that, right? Should make sense. The amount of change, a noun, right? The amount of change, a noun, is how much greater the final is than the initial. And that's how much change you experienced. But we can also say dy can be determined a different way, using dx. Okay. How can we determine dy using dx? So now we're talking about two variables changing together, right? So dx is changing. How can dy be found from dx? Any ideas? Yeah.
Because they're related, well, some constant times dx should give you the change in y.
So you want some constant times dx to give you the change in y. And what would that be about? What's the idea there? What's that called? Constant rate of change, right? Constant rate of change. Good, okay? Yeah, so if you have constant rate of change, then changes in one are a constant multiple of changes in the other. We've talked about that. We talked about that. So using dx, term dy. Here's an example. You're on your cruise control, 70 miles per hour along a flat, smooth highway. What's the meaning of 70 miles per hour? Autumn, what do you think? Okay, Jessica?
If you travel at that exact speed for 1 hour, you will go 70 miles.
Okay, so if every additional hour means an additional 70 miles traveled, that's what that means, right? Is that a good meaning for that? Leo, got a little shake going on?
If it's a constant rate, then yeah.
What's that? Is that a true statement? Okay, there's a difference between it being a true statement and a good meaning. Is it a true statement? Is it a good meaning? Narrow. Narrow meaning. Why is it narrow? No, it's constant. Okay. Leo, what were you going to say? Okay. So the point, it's not that what if you travel a different than an hour. It's that you know for any change in time, right? So because you know a lot more than this. How far do you go in 2 hours? How far do you go in 5 hours? How far do you go in half an hour? So you know a whole lot more than the fact that you go 70 miles in 1 hour. How far do you go in a tenth of an hour? 7 miles. So all these things are part of knowing that you're going 70 miles per hour. How many times could I ask a question like this? Infinite number, right? For any change in time, right? For any change in time, what? The change in miles is what Leo said. 70 times that change in time, right? So that's a broad, good meaning because it takes into account any change in time. And then we know how far you go. So for any change in time, the change in distance is 70 times the change in time. Okay? New example. Gas costs $2 per gallon. I made this. We did the same one?
Yeah.
Do it again. What's the meaning of $2 a gallon? Constant rate of change. What's the meaning? So
Narrow definition?
no, I always want answers to be the best. So can you give me the good definition?
That
The broadest, fullest definition?
for any number of gallons you purchase, multiply it by 2 to get the number of dollars for any amount that you're purchasing.
Well said. Well said. For any change in gallons, the change in cost is 2 times that number of gallons, right? So gas station wouldn't do any business if they only sold you 1 gallon, right? They wouldn't do any business. You want to go to the gas station and be free to buy half a gallon or 8 gallons or 10 gallons or whatever to fill up your tank. So then to get the cost, it's going to be 2 times that. All right. So reviewing constant rate of change here. So again, for any change in number of gallons, change in cost is 2 times that change in number of gallons. Okay, so a store sells make your own snack mix gifts. The box costs $B. The snack mix costs $2.75 per pound, which means, Kylie, you want to try it? What does that mean?
So for every change in pounds, the change in cost in dollars is 2.75 times the change per pound.
Well said. Any additional number of pounds of mix will increase the cost by 2.7 times that amount, additional number of pounds. Okay, so what I want you to do is, I want you to define all these symbols. For this scenario, right? For this scenario. So, and we're going to use the conventional, so there's kind of a ambiguity, right? So what is X, what is Y? But based on the constant rate of change being 275 per pound, we'll use a conventional assignment of X and Y. So what I'm looking for here is phrases, right? We're defining these either variables or parameters. Defining either these variables or parameters in a sentence or in a phrase so that you're really specific. So you can work on it together at your table. Hey Zeus, what did your table come up with? What did you say X was? Number of pounds of mix. Okay, number of pounds, right? And Y? Okay. All right, so yeah, the cost of the gift with X pounds of mix in it in dollars. All right, these variables or parameters? Variables, right? Because you can choose different amounts of pounds to put in the box. All right, let's move on. What about DX? Sienna, what did you guys say DX was?
So dx is the
Change
change in pounds.
in pounds, okay.
And dy is the change of the cost of the box.
Okay, change in the cost of the gift, right? Good. Variables or parameters, those two?
Those
Or maybe one of each? No, I don't want to give any.
I said variables.
You think they're both variables?
Yes.
Agree? Okay. M is?
Would you like me to say M as well?
Sure, keep going.
Okay.
Doing great.
M is 2.75.
2.75.
And that is our
Parameter,
parameter.
yeah, 2.75. That's the constant rate of change. 2.75 pounds or dollars per pound. Okay, so using these symbols, how would you write an equation that computes the constant rate of change? Using two or more of these symbols, how would you write an equation that computes the constant rate? Y equals mx plus b. That computes the constant rate. Leo. He wants dy over dx. Yeah, m equals dy over dx. M equals dy over dx. That computes the constant rate, right? Because if it's that ratio will always be constant, right? That's what is constant rate of change. Dy is always m times dx, so that ratio dy to dx is always m. Okay, write an equation that computes the change in cost given a change in number of pounds bought. Jessica, what would the equation be that computes the change in cost using two or more of these symbols? So the equation computes the change in the cost. what is the change in the cost? Which one of those symbols is the change in the cost? dy. So our equation, if it's going to compute that, we want dy equals. Britt, what would it be? dy equals what? What did you say? MDX. MDX. Is it MDX? Yeah, that's always true with constant rate of change. Given any change in number of pounds, and we could even write dy equals what? We know what m is. Either one, right? Given any change in pounds, the change in cost is always 2.75 times the change in pounds, right? That, because we have constant rate of change. Okay, let's keep moving on here. So here's a scenario. You open your laptop during class to take notes, and then 35 minutes after class started, your laptop battery had a 41% charge, and then 75 minutes after class started, the battery had a 28% charge. Okay? The percentage charge, P, and that's going to be in percent, okay, not the decimal version, but truly P we want in percent, changes at a constant rate with respect to the number of minutes since class began, T. Okay? We want to, and this is going to take you through an activity here. You're just going to follow the instructions and answer the questions, and you can work together. But and then you've got 15 minutes to work on this now, and then the finished product will be due if you don't quite get it done. That's okay. The finished product will be due Thursday, so you can just. So is everyone to the slider then? Yeah. So first of all, we need. So lots of you just typed in dx, which, oops, I already defined it in mine. But you got. You want dx as a character string to be a variable, right? Remember how to do that? Backslash, which is above the return, then dx, then backslash. And then now in your file, dx is a single thing. It's a single variable. And notice that it's saying now dx is equal to 1. Okay, so you've got the, whenever you type in n, it'll pop up the slider underneath the graph, but you can make any variable a slider by saying equals slider. And when you get done typing slider, it'll be italicized. And then you want to tell the starting, so paren, starting value, which I said negative 35. Shift 9, yeah. Yeah, it's not a function, it's just the slider command. So negative 5, comma, 55. And then the slider pops up. And then we want it to, be able to slide dx in a continuous way. So that means we want like lots of steps, right? Not just 3 or 4 steps between negative 35 and 55. So you could say like 100. And then you can grab on the button, and then you notice that the values change continuously. See that? Or some, it's the spirit of continuous change, right? It has the spirit of continuous change. Instead of, if you did, 5, then you're only going to get 5 values between, so it's going to be jump by 18s, right? It's going to jump by 18 minutes at a time. So I think if you don't put anything, it'll kind of do that, give it that continuous feel. So you could put nothing, or you could put 100, but don't put a low number. A low number will mean only that many jumps between negative 35 and 35. Okay, so now let me show you the animation. So now here's this animation that you're going to do to finish the project, okay? And what is it showing? It's showing this point here, the blue point that you should have already graphed. That should already be on your graph. That's the point, what, 35, 41? And what is if that's our initial point, what should dx be at that point? What should dx be at that point if that's our initial point? No, dx, the change. 35 minutes is our initial time. So when our animation is highlighting that, what should dx be? 0. Notice. So this is we kind of visited this a week ago, but it doesn't come easily, right? dx, this slider, is the amount of change. It's not how many minutes in class have gone by. It's the amount of change since 35 minutes into class. Does it make sense? So does it make sense that that's why I made dx go from negative 35 to 55? And not starting at 0, right? Because what does dx equals negative 35 mean? And and then when is that? Yeah, exactly. When is that? When is 35 minutes before we looked at it first? Start of class. It's the start of class, right? And then at this key reference point, the starting time of 35, dx is 0. And what is dx at our second time we looked at our battery? What's the change in x now? 40. Okay, so you're going to build this animation. This is using constant rate of change, and we want to use dx and m, right? So you've got the value of m now assigned in your file. You've got your dx slider. You're going to build this animation with dx and m. What? So what does it consist of? 3 things. This point, given a dx. What's this point here? What's this horizontal segment given a dx? What's this vertical segment given a dx? So everything's defined in terms of dx and m. Okay, so